Good morning, everyone. I think it's still morning now, right? It's almost afternoon. I hope everyone's had a good SREcon Europe so far, and been enjoying the talks as well. As I was introduced, I'm Brian Sherwin. I've been at LinkedIn for about 8 years now, and I've done a variety of roles ranging from tier 1 to automation, incident command. I gather data, and what I'm here to talk about today is about a great intersection of all three things that I've been kind of working a lot at LinkedIn about. One is detection, the other one is collection, and the other one is escalation, right? But before I get too deep into the presentation, I do like to go over a brief agenda where I talk about some of the things and kind of give you an idea of where we're going with the conversations. So first there'll be this wonderful introduction and agenda slide where we'll be talking about all sorts of stuff. And then we'll cover kind of a problem statement where we'll talk about what the problem is, and then a solution of the problem, and then some goals and design considerations if you want to solve the problem, and then some wins that we got from solving the problem, and then finally lessons kind of abstractly that we learned, and then we'll have a brief Q&A that we can hopefully get through and then have some lunch afterwards. So how this title though relates to the talk, right? So as we kind of said before, how weathering the storm and how it kind of saves the farm. It might be a bit stormy out, and if you imagine yourself as an emergency responder at your company, you get these calls where there's problems coming up, and it's your job to kind of figure out what is the problem and how to respond, and then how to get the right resources to the right people and how to communicate to them at the right time. So in that regards, we are kind of those responders that kind of dispatch and figure out these kind of abstract problems. So, but our world is not so much like an emergency responders world where we're responding to a down power tree or an accident or something. For us, we live in a world of microservices, right? And these microservices, when you compare them to what the world was before, where it was a monolithic application, is a huge improvement, at least in my part. And I'll just go over a couple of the smaller things that I think improved through microservices, and then some of the drawbacks that kind of happen and how they kind of relate. So the pattern's super common now with these microservices. And one of the good ways that they help us is that the code bases are smaller, right? Instead of having this monolithic app that does the whole thing that everyone needs to have a context on, you have these smaller code bases that you can get expertise in, but you need fewer reviewers, but for fewer people, you have less of a context on that, right? On the whole application. This application has a smaller context. And that's my son joining us, just kind of giving a talk, so sorry if I got a little distracted there. We'll be able to say hello later. So back onto that, these smaller code bases do need fewer reviewers, but these reviewers have lower context of the relationship to the whole application. So these applications, now you don't know what's changing as a whole. You know what's changing in your tiny little world. So when you do deploy these changes, since you are able to review them in a smaller size, you now know just the changes that are being deployed, but you don't know how that's impacting everything else. Furthermore, you unlock the deployment speed as well. So you're deploying much more rapidly because you're able to review much more frequently. And then at the last bit, these services are now independently operated from the rest of them, which means you need independently operating sensors and capacity planning and alerts and all sorts of stuff along that sides. So from a comparison between a monolithic app and a microservice app, you do get a lot of improvements, but now you have these problems where you're deploying more frequently because you can. You're not being able to monitor everything as easily because, well, you're not being able to do your capacity planning as easily because you need to track all of the different microservices. So let's kind of run through a troubleshooting scenario here when a microservice behaves, right? So what do we do here, right? If backend 2 has a problem, what we'll see is problems kind of percolating up into mid-tier 1 and 2. These two mid-tiers will have issues, which will then percolate up to front-end 1 and 2, and then now some user can't search for a job, and then some other applications have issues, and then all of a sudden we have this kind of like hurricane of problems coming in from possibly all sorts of sensors alerting, depending on mid-tier 1's sensor load and front-end 1 sensor load and all that, right? So from the dispatcher analogy, we're now receiving all these alarms potentially from all these different problems, but they're not all necessarily related to each other, because back-end 1's or back-end 2's problems and mid-tier 2's problems don't necessarily relate. So let's kind of run through like a default troubleshooting kind of behavior here. So for me, when a microservice is misbehaving, I often kind of follow the philosophy that I read in an article from Rob Ewishuk. It's a Google Doc that you can search for that has like a philosophy of alerting on it. But in that, we kind of talk about like you want to monitor closer to the users rather than getting the full kind of load of alerts. Like as a guy who supports front-end 2, you probably don't want to get alerts for mid-tier 2 and back-end 2. That's just not necessarily in your context realm because you don't necessarily know the changes that are coming up and the deployment strategies and stuff like that. So you generally only want to get alarms for front-end 2. So what happens now is you get like a phone call for front-end 2 misbehaving, or front-end 1 in this case. So you wake up, potentially, you kind of come online, maybe you get on and you look at some graphs, and maybe you check some logs, and you kind of take a look around, and you finally come to the conclusion that it's one of the mid-tiers is misbehaving in the front-end 2 world. So at that point, perhaps you're the owner of that service, maybe you're not. So maybe you call mid-tier 2 guys and like, hey, what's up with your service? And then they do the same thing, right? Like they check the graphs, they check the logs, and they come to the conclusion that backend 2 is having an issue. And at that point, I want to ask like the question, how fast did that go, right? Like how fast do you think you spent on that? For me, I think it's like reasonable for each on-call engineer at that point to spend at least 10 minutes plus the detection time of the problem troubleshooting that, right? And that's 3 layers deep. So I'm predicting at least 30 minutes as a reasonable kind of response of a problem from when you get the escalation to when you start troubleshooting and then when you start escalating out to the correct service. And that's a 30-minute downtime. Like, can we do something to improve that? Which leads to our problem statement. In a microservice environment, how can we detect a production issue and its cause as soon as possible, right? And so we'll need a couple of tools to be able to help us do that. One of them I've kind of already kind of alluded to in the previous slides. So we saw that kind of tree come up, right? This relationships. So these nodes have like a relationship to each other. Front-end 1 has callers to both calls mid-tier 1 and mid-tier 2. So if you had some way of like tracking that relationship somehow, you could use that to help you narrow down problems from the world. Like you know mid-tier 1 problems might affect front-end 1. In the same regards, the other side is mid-tier 2 might have problems, and you could use that to investigate issues in front-end 1 and front-end 2. But that doesn't necessarily is not the full picture that you need. Front ends and mid-tiers and all of these microservices each have an idea of sensors that are monitoring other things, but they also have ideas of endpoints as well. These endpoints need to be monitored, right? Like front-end 1 might be the profile services, displays profile data, while front-end 2 might be jobs. But you would probably serve more than one endpoint out of both of these, and they might very well have different endpoints within each application. In fact, many different endpoints. There might be a profiles endpoint or a profile services endpoint that shows you like what types of parts of the profile that you have in a relationship of like LinkedIn. So we would not only need to track the relationship of the front end and its endpoints, but we'll need to track the relationship of that endpoint to other endpoints in the stack. So if you have these other endpoints tracked and the relationship stored somewhere, you can now start thinking about problems that come up between them. And you can use that to give you more context. So for us at LinkedIn, we built a service that that builds this context and relationships based off of primarily two different input sources. One, the actual sensors themselves, because at LinkedIn, we're a very sensor-heavy shop. We have many sensors that often aren't looked at, but in the flip side, we can pretty much guarantee that we always have like a latency sensor on every endpoint. Every endpoint has a calling endpoint sensor where it detects how long that sensor is taking to service requests. We have the errors that it's detecting. We have the endpoint itself's errors. Like, we can build all of that there. Since we know that we have all these sensors lying around, and now that we've built this relationship database off of those sensors, we'll do two things with that. We will now take all of these sensors and then build alerts off of each and every one of them based off of standard deviations, so that we'll now know exceptional periods of time where things are in the sky, like 4 standard deviations outside of the normal, or 8 standard deviations outside of the normal. So now we'll know when there's problems, and then we'll have the context of problems, how they could relate to each other. So when you combine these two together, you can apply a correlation algorithm, which is kind of math heavy, so we didn't want to go into it here. We do have another talk that we do go into that, and I can share that to you if you are interested after my conversation here, and I can show you some of the math involved in that. But it's a correlation math. So when you combine these two, we can get an interesting platform that can do alert correlation between the two of them, and they will be able to do great things with that. Since you have the relationships and alerts on pretty much every endpoint sensor that you can discover in your metrics database, you can get proactive escalations for your tier 1. So your tier 1 is now receiving, in relative near time, any sort of exceptional alerts and its relationships to other alerts that are possibly coming. So that storm of alerts that you could receive of some endpoint being down that's facing users, causing potentially dozens of other alerts to fire based off of their downstreams, they can now point in more directly to the downstream at the bottom of that tree, causing you issues. Additionally, for an on-call, it's actually outstanding, because we're not replacing your alerting. We're simply creating dozens of more alerts for you and not escalating any of them to you. And you get your normal alert, and you'll be able to see these additional alerts with an idea of what downstream is impacting you, so that you can get the right guy involved at that point, because you might not be the owner of that downstream service. But it's certainly impacting you, so getting the right person involved will help you out quite a bit. So when we were designing this system, we needed to think about a few things, though. The first iterations had a couple of problems, and I wanted to kind of go through one of the goals that we used to kind of solve them. One, it needed to be relatively automated. In a microservice world, you tend to add microservices like all the time. Like, there are new microservices coming up, and there are microservices going away, and they need to be, your service needs to be aware of that and needs to be able to adapt to that. So if you can add microservices, add the alerts for them, and add them into their relationships, and remove relationships that are no longer valid, because an endpoint could be removed from one endpoint or another, that would greatly aid in people being able to use your service, especially because you don't want users to have to do this manually, because that's just a recipe for disaster. Secondly, it needs to be relatively quick as well. You don't want us to give you a recommendation that a downstream's having issues, and it being like 20 minutes old. Like, that's outside of the time context. You could have fixed the problem by then, and then all of a sudden you get someone else calling you up saying that there was a downstream issue. You would be frustrated that would happen again if it was at 3 in the morning. Which kind of bleeds into the experience. Not only do we need to be fast and automated to where that you don't have to do any hand crafted work, but it needs to be a positive experience for you so that your on-call is easier. So if you do get that call in the middle of the night, you know that our tool will have at least tried to find the downstream that's impacting you. And if it doesn't, you know it's probably you. And we do help you with that sometimes as well. So our key goals when we designed the system, just to reiterate them, was automation, the time spent, and the experience on them as well. So let's talk about some of the key design this considerations. Now, the goals are different than the design considerations, at least to some extent. For instance, one of our design considerations was to make sure that the accuracy was there, right? And we did that through a number of like tracking and comparing actual problems with recommendations that we made. Because if you give a false negative, something that's wrong, then people will get frustrated with you and not use it. And it seems to be if you miss something, like a false positive seems to be a better one, in at least the alert correlation, because that's something that you missed, not something that you kind of misled about. So we wanted to make sure our accuracy was there, and we tracked it in a number of ways. We wanted to be able to track the speed as well. So we don't want to be like super behind speed-wise. Again, that 20-minute delay on giving you the recommendation is killer for your ability to troubleshoot. You might have already fixed the problem by the time a recommendation comes through. And then to tie that back into what I also said earlier, we wanted it to be scalable as well, because we know microservices come and go, and endpoints change and get added all the time. So we need that to be super scalable and super adaptable to the existing infrastructure, and to be able to solve all that for you as much as we can. And then the simplicity as well was what we wanted to make sure that we have, because of the recommendations we give you, we shouldn't have a lot of extra data in there. Like, we should just tell you, this microservice that's your downstream through 3 other downstreams is having high garbage collection, or it's out of threads, or something along that line. You don't need to know that all the other problems between you and that one. You just want to know that that guy is probably having an issue, and here's an idea what that issue was. And then finally, we wanted to be reusable as well. So we didn't build a new alerting system. We simply took our existing alerting system and then started shoving more and more alerts into it. And we may have upset the alerting guys a little bit, but it's okay. We worked our problems out. Not only that, we also created many more dashboards so that you could, in theory, use our dashboards to find what your downstreams actually are for you. That's actually pretty handy as well, because since you're a microservice, you don't necessarily know what all your downstreams are at any given time, because downstreams can change on you pretty quickly. So we do need to update them. And having all that available to you, you could use that to like, I haven't touched this microservice in 3 months. Let me go see what my downstreams are, because they might have changed on me. And you can see that, and we'll update that for you so that you can use that to investigate any future problems on your own. So those were kind of like our design considerations here: accuracy, speed, and scalability, and simplicity, and reusability. So let's give like a 10,000-foot view here of the whole system. This is it right here. It's really kind of two main components, I guess. We have a data ingestion engine and a correlation engine, right? So we have something ingesting all these alerts and something making the correlations from them, right? And so we have that alert pipeline that we're sucking in all these thousands upon thousands of alerts that we've created for every microservice that we could possibly ever find in the metrics service. We combine that with the relationships that we were able to determine through call trees and traces and the actual metrics that we have in the metrics pipeline that we do have. And then we apply one more very useful thing, the deployment data, because most of the time problems, well, not most of the time, many times problems are caused by deployments. So if we can combine deployments to get an idea of when a deployment happened, that usually gives us a useful start time for what the problem actually was, right? For instance, if some app has a deployment that rolls through 100 app nodes, and they take down 10% of it, that is going to lower the capacity, and that might come up as like a latency issue or a thread issue for that particular service. But the real problem is there's a deployment ongoing. It would be more helpful for us to give you the deployment data. From those 3 basic input sources, we come up with a correlation result that looks like it's like a little miniature stack trace of your service, your next tier service, your next tier service, and then your thing that's probably broken, and a link to the thing that's likely broken. And we give that to you in a number of locations. We can send it to you as a direct message, an email, or directly through Slack or Teams in the future. We could give you an on-call ring if you really wanted that, which we're trying. I would imagine you probably don't want that necessarily, but some people do want that still. Like if they trust our correlations are so much more useful than their actual monitoring, that they'll just take what we think other people's problems are. And we also have a web UI that you can use to search for existing problems as well, so that from that. So let's talk about some of the wins that we saw. So when we got combining the relationship data with the alerts data and putting them together with deployments, we were able to detect about 90% of all major incidents. And that is roughly every incident that doesn't involve some sort of generic system like DNS having an issue. That's very hard to get a correlation for DNS having a problem because everybody starts catching fire.
100% though, won't it?
Yeah, it won't be 100% on that. Yeah. But the other things like networking outages as well, like everybody loves to blame the network, but it's very hard for us to detect that it's a networking problem. That will manifest itself as individual app problems. And that is something that we're looking into being able to fix as well. The win that we got, since we were able to give you an idea of what exactly down your dependencies was broken, that really helped us drive team adoption, right? Like, so people would see like, oh yeah, I got this alert from my external testing system that my service was down. And then I went to the alert correlation system and saw that my backend, my data store was broken. I no longer have to spend a lot of time investigating this. I will call the guy who has to fix that, and he will go fix that for me. And then we will all be very happy and celebrate a certainly shorter outage period once it's done. But the most important thing we found, and the two most important things, was actually catching hidden issues. So, this is something that we didn't realize was such a big problem. We added alerts for everything with thresholds that were reasonable. And we added them everywhere, all the time. Apparently, not everybody was monitoring everything. We were shocked that not everybody was monitoring their latency, especially on some low QPS service that they never thought of, that they actually owned. And since we were able to add that, we started detecting problems. Now, in their defense, they probably didn't want to be escalated when a service that takes 4 QPS has a 400% latency increase. While it's probably important, it's probably not important enough to wake you up out of bed for at 2 in the morning. So, but we added that into that, and we started monitoring it. And then instead of calling you about it, we looked for your downstream that had an issue. And then if you did by some other calling person for you or in the night, you could look through and be like, oh yeah, you did have an issue last night, and it was because this downstream was having an issue to you. Maybe you can call them during the day and like figure that out. That was super valuable for us and for a lot of different teams, which kind of leads to the cultural change as well. Since we post most of these items to public channels, 24/7 all the time, we still believe that you should have your own monitoring. And my own personal philosophy is you should have your own monitoring close to the end users. So when you do get that page saying your service is down or your users are unable to log into your system, you can go to whatever public channels that we're posting the stuff that's relevant to you, and you could look and be like, oh yeah, that's what that was. Or sometimes you might not have had, your alert settings might not have been sensitive enough, right? So you would see these users kind of gather around and see like an alert correlation message come up saying that here's a downstream that's having an issue, and the on-call would be like, I don't even know that was one of our downstreams. And then they would be like, wow, that's something that's up on that. So that really helped people kind of shift that kind of culture towards monitoring and collaboration in terms of finding the right people with the best context to investigate. And then so I'll go through kind of like the more abstract lessons that we learned here in case you're interested in implementing this on your own through your own correlation engine of some sort. One is, I've mentioned it many times already, the speed is like super important. Like if you can get within seconds of finding the problem, and give them a downstream that's having an issue, you can help with that. And then secondly, you get that speed partially by pre-calculating everything. So in our case, we are pre-calculating the relationships tree and updating it constantly in an offline process. And additionally, we are looking for every sensor that looks like an HTTP sensor or a latency sensor and adding an alarm on it and using that as input. And just constantly injecting and updating thresholds for that as well. We do drive the ingestion as well. So when you create potentially tens of thousands of alerts, you need to be able to ingest tens of thousands of alerts very frequently. So the pipeline for ingestion needs to be very optimized. Because if you're spending your entire time trying to consume that fire hose of alerts that you've created and can't get it done fast enough, your speed will go down because you're not able to accurately come up with solutions there. The hierarchy is super clutch, building that hierarchy. However you do it, we use a combination of a few methods, one of them being the call trees and traces, plus the metric sensors that are implemented on each endpoint. So we combine those to build a hierarchy of endpoints that we kind of know what services are calling what, and give you that information. That was super useful for us. And then validation is actually something that was very valuable as well. Validation in the sense that when you're looking at all these call trees and latency metrics and your downstreams are having issues, what you need to check as well is that, are you having an issue? We used to give somewhat erroneous recommendations because we weren't checking to see if your actual service was having memory pressure or thread pressure or some other levels of pressure coming up. So if without validating that, you end up in trouble there. The accuracy is also super important, being able to track that. So not only be able to track when your accuracy was good, but know when you're not so accurate. So either through user feedback and communication with the users, or in our case, what we do is we try and map the recommendations that we gave to actual problems major problems. So we know that 90% of the recommendations that we give are related to major problems in some way. And then one thing that was also useful was the evidence that you give. Give the evidence. Don't just say it's one service having, here's the service name. Give all that evidence that you've been able to build up. The alerts that you have, the dashboards that you've created. Just give a very short summary with some key data there, endpoint 1's latency sensor is high on this app, which relates to this app's latency sensor being high, which relates to this final downstream backend having high thread utilization, right? So give that to the user, and then they can take that to the actual team having the issue and ask them about it more directly. And sometimes they go, where did you get this data? And it's well, the system just kind of created it for us. The adoption, you should also be tracking as well. So just keep talking to people and trying to figure out why people aren't using you, and then work with them to get them to be used by us. Find out why they're not using it, and then there might be a feature missing, or they might not have the knowledge that's needed. Just get them involved and get them using it so that they can begin troubleshooting these things. And then finally, store the history as well. So we like to be able to play back the clock a little bit, so we know the last 6 months of recommendations that we gave and the relating alerts that we got. So if we get these histories, we can track this history and store it and save it up and replay it for people as well. So if you're oh, what recommendations you gave me 6 months ago, just show them all to me. Give me an idea of what my problems were. We can give that to you, and you can use that to help plan perhaps resiliency planning, or making it to where you're less likely to be impacted by downstreams having an issue. So some next steps here. So we do want to add one more thing, a few more things, not user-based monitoring inputs. Because as I said earlier, we have this idea of external monitoring through a vendor that's downstairs in the vendor hall. if they detect a problem, we would like to be able to use that as like a trigger to relate that to a problem so that you can know a more concrete user problem, like what the users are actually experiencing. Because alarms and metrics don't actually tell you what's broken. They tell you how it's being broken, but not what does that actually mean to the end user. For instance, like a high latency could be that, what does that mean to an end user, right? Like, does that translate to a page not loading? Does that translate to an error page? Does that translate to like I don't know. But with a test like this being done at the end user level, you would know exactly what's wrong, and you could use that as further evidence to help people escalate that faster. And secondly, we would love to tie this into remediation actions as well. Like if you could somehow tie into like a plan to roll back, like this change occurred, I want to roll back whatever downstream change happened so that I can get out of the fire really quick. That would be very useful as well to have that into the future. We don't have that today, but that would be super handy. And then just some contact information from me on that side. So you can contact me at these 2 locations, and I'll be around, kind of floating around for any questions and comments on that. So we have a few minutes. I think I'm pretty good on my timing that I planned was about 30 minutes, so we should have like 10-ish minutes for some Q&A if anybody wants to ask any questions on various topics and things.
Yeah, we have some roaming mics here for questions. Yeah, if you've got questions, put up your hands and we'll come down to you. And as always, questions in the form of a question, not a comment.
Uh-oh. There have been comment questions.
Hello, and thank you for your presentation. As far as I understood your talk, the thresholds for those thousands and thousands of alerts that you're auto-generating are also auto-adjusted. Does your system incorporate any user feedback about false positives? For instance, the system may decide that this is an issue that a person should be paged, but the person looks and sees that actually users are not affected, and it's all within from his point of view, it's all within the limits. And can he tell the systems that the threshold must be adjusted?
That is a great question, and we have accounted for that in a number of ways. So first, 4 standard deviations is our first threshold, and then 8 is our next. So if your latency is 8 standard deviations higher than what it normally is, that's usually pretty fatal of an alert. And then 4 is pretty severe, but maybe it's still working. But as far, so that kind of winnows the problems down to actual like on fire type of things. Secondly, if a singular alarm is being misfired, we won't be able to get a very clear downstream recommendation for that because it will be just a singular alarm. And we won't display that one. So we will try and run a correlation on that, and then we'll come up with a very low confidence score on the correlation because we won't have a lot of corresponding data to like back that up. Generally, from the earlier slides, you saw that like if a downstream's having an issue, that you will usually percolate up into multiple other downstreams having an issue. And those downstreams will generally also have alarms going on, and then that will help us give you a high confidence score instead of a lower confidence score. So we'll generally not even show you ones that are lower than like 0.7. So a singular mistuned alert will be like a 0.4 or something.
So you're basically mitigating the false positives using statistics?
Yes, yes.
Thank you.
Yeah, hello. Yeah, I have. Could you please talk a little bit about a business side of that system? Because there's a lot of smart things you can do to alerting and monitoring, but how does the whole thing pays off, basically? So, because I assume it has a lot of costs involved. So how do you sell it all to the business? How do you get it buy-in? So how fast this pays off, basically? How do you have this conversation with the business?
That's a great question. We have our primary operating flow for it involves, we're not advocating replacing your monitoring, right, as an application owner. What we're advocating is you should keep your own monitoring going for when you get escalations, But what we'll do is we'll post into public locations and searchable locations for you that will indicate where we think the problems are, even if you didn't have any monitoring turned on at all. So you could see like, oh, I got this page. Let me go to my channel that I set up that tells me about problems that might be involving my applications, and look in there and be like, oh yeah, that's like a deployment going on for one of my downstreams. I'll go ahead and like acknowledge this alert for 20 minutes and I'll come back to it later. That's kind of like one of our common workflows that people use us for as like an aid for limiting the time that they spend troubleshooting an issue. Does that help answer your question?
No, my question was like, if we basically decided to do something like that in our organization, so what would be the approach to business to explain the ROI basically of the whole system?
Oh, the ROI could also be along the lines of lower time spent on troubleshooting issues, because when you have those multi-tiered microservices, each team is spending potentially minutes investigating problems and being escalated to. So your time to identification of the issue should lower, so that your time to fix should also correspondingly lower. So your outages should be able to be identified as the root cause faster and then be fixed faster as well. So
yeah, because sorry, my assumption that if you only talk about the cost of mitigating the labor costs to resolve the outages, it wouldn't be sufficient. So you probably factor something else on top of that. That was.
It lowers on-call toil as well. From that perspective, like for LinkedIn, the on-call toil is something that we try to reduce all the time, and being able to get our on-calls to the problems faster is a value that we've decided at LinkedIn is something is worth spending some money on, and investigating ways to reduce that as well.
Okay, thank you.
Any more questions over at this side?
Uh-oh. Anybody?
No more questions?
Going once, going twice?